Actually, if you want to, Bakari, on the hit the third button from the top. It should make this look a little cleaner when the text is up there. Big money. All right. So we're supposed to write a bunch of these functions here, right? So index of returns the first occurrence. Is this spelled right? Of C in S or -1. So this is kind of the Java version of that guy. So we're going to pass in a char pointer, which is a string. So remember the way these guys line up in memory is strings are character arrays and they're stored in contiguous memory. So what we're doing here is we are pointing to the base address of S. What's the very beginning of that string? Then we're also passing in how long is that string. So we know how long we're allowed to dance down through memory, taking char size steps before we walk off the end of that array. Because in a language like C, we can walk off the end of an array. Where Java is going to scream at us, say array index, out of bounds, exception, blah, blah, blah. All right. So we are going to go through every element of S, checking to see if it's equal to C. If it is equal to, checking to see if the value at that position is equal to C. If it is, then we're going to return that position. If we get through all those things and haven't returned anything, we'll return a -1. Okay, so we'll have our int I, and wasn't the caveat here we had to use all pointer math? We can't use any no square brackets, right? All right, so int I will say for I is equal to 0, I is less than length, I plus plus. All right, so that's kind of our stock go through every element of a string or every element of an array in C. Pretty similar to what we've run into in Java, with the exception that we couldn't ask S what its length was. Make sense? All right, so each time through we want to ask the question, if the character we're currently looking at, if the value at a position in memory is equivalent to C. So I want to look at my current position in memory, which is going to be AR plus I times size of char. All right, so this guy is a memory address, correct? And I want to get the value at that memory address. If the value at that memory address is equivalent to C, return I. Otherwise, we'll just keep trucking. If I exit this for loop without returning anything, I'll return a -1. Does that look good for index of? All right, questions about that one? I guess for the sake of whatever, we can test this real quick. Did I add these things to my header file? I have not. So I'll go ahead and add to my blah.h my prototype for that. We didn't actually have to give it the variable names. Okay. So then for my answer, I'm going to set this guy equal to index of, and I'm going to pass it my string S. I'll pass it my length, where my length is actually, in this case, going to be 5. I'm keeping track of the length of that string. If you want to pass 50, that's okay, because it won't match /0. So either one will end up working. You're just checking a bunch of empty memory locations. So I'll just pass 5 for our example here. And then we're looking for maybe an L. So this should return 0, 1. This should return 2, the position of the first occurrence. And then we'll go ahead and print out the value of answer. All right. Create a string capable of holding up to 50 chars. Fill it with hello. Call my index of, passing it the string, passing its advertised length. So anything 5 or greater would be okay here. I'm just trying to make it a little bit more efficient the way we're calling it. The guy we're searching for is an L. This guy's going to come in. He's going to take in the S. He's going to take in the 5. He's going to take in the C. We're going to check the value at the base address plus 0 initially. So the very first bucket, which should be an H, we're going to say is H equal to whatever's stored in C, which in our example here is L. It's not, so keep trucking until we finally get to the first L, which is at bucket 3. Is it bucket 3 or 2? Where am I at here? 0, 1, 2, bucket 2. So we'll return a 2. Okay, so let's run this guy. Oh, I didn't name it AR. I named it S, didn't I? Name of my array or string is S, not AR. And I used a capital OF there, so I need to call it by the same name here. It is case sensitive. Previous explicit definition. Oh, I'm not including my header file. When did we take that out? Remember, we were looking at header files versus prototyping, so it knows about my index of function now because I put it inside my header file. Now it should recognize it when we get down to that line. There we go. ./a.out. Oh, I'm still entering in some string stuff. I'm not entering in some string stuff. Is this not actually saved? It said it was saved.
It's saved now. Just set all the changes. You still are entering some string stuff though.
Am I?
Yeah, it was print up interesting. Right underneath your end answer.
Oh, why am I doing that? Where's my output? So takes in a char S.
I'm not printing anything.
You're right, I'm not printing anything. See, I told you. Every other. %d \n answer. All right. Bucket 2. Hercules, Hercules. You get that movie reference? What was the name of that movie? It's the Eddie Murphy movies, where he played all the characters. Big Mama. Yeah. All right. So now let's pass in I don't know, a Z or something. We should get a -1. All right. So there's our -1. So that's index of. All right. Char at should just return for me the position, and we can assume that we're giving you a legal position of what you're looking for. You know, we don't have to, if you wanted to error check and say if you give me something less than 0, I'm going to scream at you. If you give me something greater than length, I'm going to scream at you. We'll just have it go ahead and return it. So I'm going to return the value at the base address plus index times size of char. So technically for this one, we didn't actually need the length if we are presuming they give you legal input. You do need the length if you want to be able to ask the questions, is the index you gave me legal? Because technically this will return the value of any character relative to the offset of, I mean, I could pass in -7 for index. And as long as the base address wasn't too early in memory, it should give me whatever lives at, 7 char steps to the left of the base address of this, whatever happens to live there. Okay, so this is direct memory, whatever. Okay, so let's test this guy. So I'll go back here. We're going to call our char at. We're going to pass it S. We'll pass it our length again for, even though we're not necessarily using it. And then we'll say, give me the character at index 0. Now this is actually be pretty interesting. Notice I'm storing that inside of an int. All right, but this guy is designed to return a char. And then I'm going to print out %d. So I'm going to run this real quick. Oh, I didn't prototype this. I only put the first one in there. Oh, did I? Thank you. Testing you. You passed this time. Nailed it. All right. There's that. There's that. There's that. All right. Should be happier now. All right. So we get 108, which is the ASCII value of, well, I asked for 2. Should be ASCII value of L. So notice here, if I come up here and I say, this is a placeholder for a character. There's my L. Even though I received my answer as an int. Make sense? So remember when we first learned about Java, we talk about how chars are actually unsigned 16-bit. Well, in this, it's an unsigned 8-bit integer because it's ASCII in the C language, where Java's Unicode, which is 65,536 unique characters. In C, it's ASCII, which is 256 unique characters. So what I'm doing here is, even though char out returns a char, chars are actually integer types. They're actually unsigned integer types. So I'm allowed to capture that inside of an int. No problem. Java would have given me an error here, right? It would have said type mismatch, unless I specifically had cast it to an int, forcing the char to reveal its integer self or something along those lines. All right, so C will let me do this, but then when I want to print it out, I can decide how I was printing it out. Do I want it to be treated as a character, %C, or do I want it to be treated as a int, which would be %D? At the end of the day, whether I said char answer or int answer, the behavior down here wouldn't have made a difference. Because if I would have said %D here, it'll still print out the Unicode version of that. Or the ASCII version of it, which is actually, with the modern GCC, it probably is the Unicode version now. But I promise you, in the original days of the original C compiler, very early C compilers, it was ASCII. That kind of goes down to some of the things I mentioned last class, where we might hit some zigs and zags here, where GCC has updated for modern times. So we might run into certain things that work today that wouldn't have worked before. For example, you mentioned size of last class for being able to ask an array how big it is, or that wouldn't have worked in the early days. Completely makes sense why that works now. I mean, that's helpful. But in the early days, we had to pass around how big memory was, and we see that as a leftover from this, right? Okay. Most C++ programmers, they don't write it like this. They write it as a char pointer array with the square brackets. But because we're cool, we don't use square brackets. Right, Muaf? Yeah, no square brackets. Gives us rashes. Yeah, rash. Like you get like, yeah. Just like using Windows in the early days, like when Vista first came out, kind of the same thing. Or using any Mac OS prior to OS X. Any of those was equivalent type of problems. Okay, so is that chart? We're happy with that? All right, just walk in memory, no big deal. Okay, so now reverse string. So we have some options here. We can, so notice here I said return a brand new string. That is the string I passed it in reverse order. So I'm going to need to allocate some new memory, right? So I'll create a char pointer. We'll call this guy answer. Okay, and this guy is going to be equal to malloc. And actually, I like writing the char pointer version of malloc, even though I think you pointed out last time that it implicitly will cast it for me. Historically, it wouldn't have. Say this again. I thought you mentioned this last time. I know what you're talking about. Yeah, but you didn't mention something about this? I thought somebody mentioned something about this last time. Oh. Yeah, I don't know the exact, I mean, I actually suspect that I didn't have to put char pointer here. Historically, you would have to. So I'm being extra explicit, I guess, and I don't know, just I'm stubborn. All right, so char pointer answer. So I'm going to give it the char pointer version of what malloc returns. That way I guarantee I'm going to take the right size little steps through memory, okay? So malloc, and what am I going to do? I'm going to create length times size of char. So that should give me enough memory to hold that dude, okay? So now what I want to do is I want to walk through, so we're going to create our for loop that's going to go through every element of S. We'll see if I can make it S first time this time instead of AR. So, so we'll say int I, then we'll say for I is equal to 0, I is less than length, I plus plus. So this will go through every element of that guy. And I want to build it into answer in reverse. Alternatively, I could walk this guy in reverse and then build answer forwards. Doesn't really matter which value I'm going to work with. Now, I'm going to create an int j here. And we're going to start I off at 0. We're going to start j off at length minus 1. And then each time through, we're going to say j minus minus. All right. If you didn't like defining two variables in here like that, that's fine. You could have just modified j inside the for loop. You know, whatever made you most comfortable. This just allows me to create two different counters and modify them differently here each time through the loop. Make sense? Okay. So I is going to be my index through S. J is going to be my index through answer as I'm flipping stuff around. So I'm going to say the value at answer plus j times size of char, that value is going to equal what value? The value that lives at S plus I times size of char. Make sense?
Why do we need to put size of char?
Because that's the size step. That's the the size step I want to take.
Otherwise, it would just jump randomly.
Yeah, because if let's say I said size of int there, it's not jumping randomly. I'll take too big of steps. If a char is 1 byte and an int is 4 bytes, let's say, and I tell it to take a 4-byte step, I'm actually hitting char 4 instead of char 1, or char 4 instead of char 2.
Well, my app got terminated. Signal something.
Yeah, you walked right off. Yeah, you hit something nasty in memory. You walked off the end of something. Yeah.
So it does have some protection.
Well, not necessarily. It depends on where you walked into. So if you just walk into another variable space that was one of your variables, it's not going to protect you against that. Or like historically wouldn't have. It's possible it does now. It's possible your application actually runs in protected memory. It would actually make sense in modern Linux for it to work that way. But that's not the way it used to work. Yeah, so I mean, remember that no matter what we're doing here, all of this, so what this guy right here is, forget about any scariness associated with it. That just says how far from the base address do you want to go. So I'm going this many steps, and the size of my steps should be that to get to the correct bucket, the guy I'm looking for. That make sense? Yeah, so I mean, if you could just put 1,000 here if you wanted. C doesn't care. You're just taking some giant steps then. So your chances are you're not working with legitimate things at that point.
In this case where the size of the char is 1 byte, would you still recommend putting that in there?
Yes, because you're not guaranteed it's 1 byte. In fact, I suspect it's not 1 byte anymore. I bet you it's 2 bytes.
I didn't put them in.
Huh?
I didn't put size in char.
You put 1 in?
Yeah, I just said.
Oh, okay. Then it's treating them as ASCII. Like a few minutes ago, I suggested that the modern compiler might implement chars as Unicode, which would be 2 bytes, right? Therefore, putting 1 would step you a half a character, which would get you some very interesting encoding, probably, with a nice little twist at the end where you have a byte and then whatever was left over, the next thing for your character, kind of a surprise. Okay. What was I doing? Oh, yeah. So we're going to say answer at that. Basically, all that says is answer at bucket J. We're using Java lingo. It's saying answer at bucket J in a really cool way. Right? So answer at bucket J is going to equal S at bucket I. Really feel like we've used our language now. All right, so that's gonna do all the whip around stuff, and then in the end, I need to return answer because I'm returning a brand new char pointer. All right. Oh, I need to prototype that. Probably should just prototype all of them right now, but I'm not because I like to live dangerously. You already saw today, Brendan, that I tried to write programs where I never printed out a result and I expected it to print anyways. I have high standards. All right. What was I doing? Oh, yeah, so we'll go ahead and get our char pointer answer here. This guy, what did I just call reverse? What did I call it? Reverse string. And I'll go ahead and pass in my S. And I'll pass in the length 5. All right, so this is going to call reverse string. Internally, it's going to build a brand new string, spitting out answer as my updated string. I'll go ahead and print out the string version of answer, which should be hello in reverse. So there's hello in reverse. Okay, next one is reverse string in place. So let's go ahead and prototype this one right now, since that's fresh in my mind. And I actually think it's not an error to put the actual variable names in there. It'll let you put the variable names in there just fine. Historically, people wouldn't. So I guess I don't know. This is probably just old knowledge, but you should expect if you look at header files that they probably do not have parameter names if it's an older header file. It just shows the types that it's expecting. All right, so reverse string in place. So what I'm going to go ahead and do is I'm going to say char pointer answer is equal to reverse string, passing it s in length. I'll let that guy do the reverse stringy stuff. And then I'll just say s is equal to answer.
But you did allocate the memory.
Yeah.
Hence in place.
Huh?
So if you said in place, you cannot have any memory. You cannot allocate any more memory.
Okay, I get what you're saying. So let me do it this way, and you'll see that it works. But depending on how you interpret it, you're right. Yeah. So let me do it this way because I'm guessing that maybe a third of the class gets what you're saying. All right. So this will seemingly give me the right answer, right? Okay, this will seemingly give me the right answer. So now we'll come up here. We'll call reverse string in place. And I do not have to store the answer there, right? Because it doesn't actually return anything. And I'm going to print out S. And S should be hello in reverse, right? I'm passing hello in, and I'm expecting it to change my original hello to itself in reverse. So what does reverse string in place do? It goes ahead and calls reverse string, which should get a brand new string, which is the reverse of the original one. And then I'm just overwriting the memory address that lives in S with the address that was returned by answer. So I'm changing that in memory. Okay? So ruh-roh. Why didn't that work?
Our pointer.
No.
Memory address of S here.
Yeah, I bet you. Do you have to do that? If it's the address of answer, is it how it's treating the string? Value at S is equal to the address of answer. So S is a char pointer, answer is a char pointer. I'm setting them equal to each other.
So inside reverse string in place, print out the memory address of S and then do it back in main, and you're not going to get the same memory.
Yeah, that's what I don't like. A char pointer should be the memory address. So you're saying that if I print out the address of S up here,
And then inside the method, you're not going to get the same memory address.
printf %p \n, and we'll go ahead and print out S. So that'll be the memory address of S, right? And then we'll print it out again inside of reverse string in place. That'll give me the address of S. Those guys should be the identical address. They should be, is the idea here. So I take it this is related to the question you asked? Okay. So let's see. So I have S. I'm going to print out the address of S. Great. Then I'm passing S in to the reverse string in place. First thing I do inside of reverse string in place is I print out that memory address. They should be the same because I'm passing in a pointer. But I believe you when you say they're not going to be the same. Two different addresses. Interesting. So a string is being passed by value, not passed by address.
It's interesting because they're the same on my machine.
Let's try something. Yeah. Because we're using this online Linux. So this is going to be actually fascinating. I love fascinating things. So vi blah.c, paste all that stuff in there. Then I'm going to need to give myself my header file as well. So this should be a real-time view of kind of differences in compilers. So what's the name of my header file? Blah.h. GCC blah.c. Oh, it's just a warning. We're fine. That's one of the other ones. Are you using CC or GCC?
GCC. That's interesting.
What are you using? The latest OS?
Yeah.
If you type in GCC -- version, what version of GCC do you get?
Same one you have.
Check the one on
Well, no, because she's using the Mac terminal. I'm using the Mac terminal here. And she's saying she's getting identical memory address, and I'm getting not the identical memory address. And you're writing yours the same way as this?
Yeah. Or as I can tell, it's the same.
There's no man page for GCC? Okay. I want to see if I could just force GCC to be like super old school.
You can tell what standards you use. C99 as well. Yeah,
Okay, dash std equals. What's the older one?
99. Well, there's 98.
The default is no C language dialect.
I like when I looked it up online, I don't get why it would work at all on anything because it's like online it says the C language is passed by value without exception. Passing a pointer as a parameter does not mean passed by reference.
That's not right.
That's why I was so confused.
Let's using a pretty old. Okay, so here we'll test it this way then. I'm gonna go back to this. I'm gonna change this guy to a int pointer AR is equal to int pointer malloc 50 times size of int. Then we'll go ahead and print out AR here. I'm going to, we'll just have this guy take in a int pointer for, well here, just for the sake of argument. We'll have it taken, it's the char pointer, and then I'll also just have it taken an int pointer real quick. So strings are treated differently. I want to say that's not the way they worked at the beginning, but I'm not 100% confident in that. But then the bigger puzzling thing is, why is she getting the same address for char pointers? Because you see, I've done the exact same thing here, right? I just happen to use an integer pointer instead of a char pointer. And we get the same address.
The thing is, though, it's still not complete. It's still not printing out the reverse string from main, even with the way it is, because that integer, that pointer never gets updated to the answer. Even though it'll update it in the reverse string in place method, when you come back up to main, it's still looking at the other one, which I think kind of goes to his comment about it being passed.
So you're getting the same result as mine, but you're getting the same addresses.
Yeah, right.
So I'm getting two different addresses, which make my result make sense. You're getting the same addresses, which make your result not make sense.
Right.
Because it seems like you're
Yeah. It's basically it's just passing the address is not actually. Yeah, I'm not. But yeah.
I just
it's
wonder.
Not editing that.
Yeah,
that
I wonder.
variable.
But I wonder why you're getting the same addresses. That's the new mystery.
That's the odd thing, is that I'm getting it here not.
Okay, so having said that, if we're going off of what Corey said, and this doesn't actually break anything for the homework, really, because as he pointed out, we should be changing it in place, right? All right, but let's get it working the way I'm saying. So if I go back here, just to get this to work. So I'll go ahead and dump this. There's our S, reverse string in place, SAR, print out S. Go into blah, get rid of this int dl thing there. Save that. Test C, reverse string in place, get rid of this guy. Get rid of this guy. Okay, now we're back. So you're going to have him take in a pointer to the string. That's what a char pointer would be in this case. So assuming whether I'm right in saying that it didn't used to work that way or not, I'm not confident. I'm not confident in that. Clearly, we know that in modern languages like Java, strings are treated as special cases. I really feel like they weren't in the early days of C, but it seems like they are treating them as a special case here. That a char pointer is a string and it's in protected memory or something like that. So I'm going to pass it a pointer to this char pointer. So that is, where does this string live in memory? Considering that the string is the string value, it's kind of protected, it's encapsulated. Which then means when I get to here, I get my char answer, what I'm going to say is I want the value that lives at S. Let's see, actually S is the value that lives at S should be answer. And then it should reverse it. Oh, I need to when I call reverse string, I need to pass it the value at S because it was a char pointer. And then did I change this? This needs to be char pointer as well. Just saying I already had a definition of reverse string in place because they took two different parameters.
Up in main, you probably didn't change that to the
Oh. No, I just was still passing in my integer array.
You need to put a.
Oh, yeah. The address of S for the char pointer. So there's my hello. Okay, but as Muath pointed out at the beginning, just to kind of, if you missed what he was talking about, if I do a printf %p \n here, and I print out s, and then I do it again here, even though it is reversing, they're going to be different memory addresses. For correctly so. They will be different memory addresses. Okay, so his argument would be, I technically have not done it in place. S still points to the reverse version of it, but S has now moved to a different place in memory. Okay, so I would say that that if you did it this way, it's acceptable. Okay, but his argument is, look, technically you left your place in memory. You went to a new place. Okay, which is a fair enough comment. So let's write it that way. All right, so with that in mind, I'm not going to be able to, well, I actually could rely still on my reverse string. I just can't copy it directly. So now what I would do is I would do int I comma j for I is equal to 0, j is equal to length minus 1. Keep going as long as I is less than length, I plus plus, j minus minus. All right, so now what we're going to do is we're going to copy the contents of answer over the same position in S. And actually, I don't need 2 counters. I'm being redundant from what reverse already did. I didn't need to use reverse. If I was going to use 2 counters, I could have done it all here, but I'll use reverse to do the thing. Now I just need to walk through both strings from beginning to end and just copy the stuff from answer over what's currently in S. So I'll say the value at AR plus I times size of char is equal to the value that lives at answer times I times size. Oh, it's plus, not times.
You did AR again.
Did I? I was testing. Answer plus I times size of char. So that'll copy it over. Then I won't change the address of S. So now S should have the reverse version of itself in place. They should be the same memory address. Oh, this guy's still taking in a, we got to go back to the old version of this. Because now, oh, no, we can't because I don't get the pointer then. Still need to do it this way. So actually, you need to say the value at S. No, that's the string. So S is a address. I want to say the value at that position. Okay, so that guy is correct. That side's correct. It's this side that needs to be different. So is this the value at the value? So you said you were getting a segmentation fault because what we're doing is we're breaking the pointer here. So I just leave it like this. What was my error message I got here? Assignment makes pointer from integer without cast. Actually, let me try to run this. Okay, we got different memory addresses. Because I'm overwriting the value of S. This says set S at a particular place, and I don't want S at a particular place. I want star S. Very interesting. Huh. All right. Well,
Because the first value will be the termination function. Backslash 0.
no, because that should be, I'm doing less than length, so it shouldn't be. All right, so let me just look at the book real quick. I won't give you a normal homework assignment because we'll figure this out on Monday. Just look here real quick. What have you read up to in the book at this point? Chapter all of 2? Well, where are you supposed to be?
Oh, it's start chapter 2. So goodness.
Oh, I see. So make sure for Monday you're through 2.14. So that'll get you up through strings. Sound good? All right. I will see everybody on Monday. Remember, Bible homework is up. It's due midnight on Sunday because I got it up late this week.
Part of the problem we may be running into there too is because we're studying as a string literal. So C treats it differently. He said it's a string literal. Like string.
Yeah, I think you're right. Yeah.
I think so, yeah.